Multiplying by the reciprocal is very useful and powerful because it helps us find precise fraction or rational solutions really quickly. So 4/7 of some quantity we don't know y equals 10. In the examples we saw before, they all came out to integer solutions. They were whole number answers that made things seem very simple, but in real life we don't always come out to whole numbers. We come out to rational expressions sometimes, the values in between our integers or in between our whole numbers. But our same strategy still works. We can still multiply by the reciprocal. So we have 4/7 y. We want to know what 1y is. So we're going to multiply by the reciprocal, which is 7/4. I could say 28/28 and simplify to say 1y, but I think we're past that now. We can just go on ahead and say we know we have 1y, and we want to know what it's equivalent to. So we're going to multiply this by 7/4. We have, again, a long way and a short way to do this. I won't always do this, but we'll go ahead and remind ourselves that there's a 1 here, which means y must equal 70/4. This is a correct solution. It's not simplified, it's not a mixed fraction, so I wouldn't advise stopping here, but just take a checkpoint here and know that this is a correct solution. This is equivalent to y, 70/4. Let's see how many times 4 goes into 70. Well, 4 goes into 7 one time. We say 1 times 4 is 4. Drop a 3, because we subtract, bring down the 0. How many 4s in 30? Well, 7. We have 28 here. 7 times 4 is 28. Our remainder is 2. We could make a decimal here, make a decimal here, and find the decimal equivalent here. So after the decimal point, there's infinite zeros. 4 goes into 25 times. We have no remainder now. So we could say that y also equals 17.5. This is totally accurate and acceptable. Still not my favorite way to do it. Pause and look at this if you need a little more help with long division. We're going to do it again here. This time I'm going to show you my preferred way of solving with fractions. So 4 goes into 7 once. We subtract and get a 3. 7 times 4 is 28. We know our denominator is 4. So we now have y equals 17 is our whole number. We know we're going to have it over 4. 2 is our remainder. We have 17 2/4. This is not complete because we need to factor out a 2 from this 2/4 and see if this is equivalent to 1/2. Y equals 17 1/2. I need to show you yet one more way to think about this. Cross simplifying. Let's say that we have 10/1, which we do, times 7/4. Do we see common factors here? Well, 7 and 1 can't be simplified, but 10 and 4 both have a factor of 2. If we divide 4 by 2, we get 2. If we divide 10 by 2, we get 5. So now we have 5 times 7 is 35. 2 times 1 is 2. This is a much better improper fraction to work with. The same way we have 70/4, we could have said y equals 35/2. How many times does 2 go into 35? Well, 2 goes into 35 17 times. 17 times 2 is 34. We have 1/2 left over. We're going to do something similar over here with 3/5 p equals 16. We're not going to get an integer solution. We need to recognize our reciprocal of 5/3. I'm not going to show every single way of doing this here. Just going to go ahead and pick one. We don't have a common factor here. We can't factor a 3 out of 16, so it looks like we're going to have to just do this the long way. We know we have 1p, and we know we're going to have 16 times 5/3. 5 times 10 is 50. 5 times 6 is 30. 16 times 5 is 80/3. Since 3 doesn't go into 80 evenly, this is an acceptable improper fraction as an answer. Really quick, we'll do some scratch work here. We'll say 80 divided by 3. 3 goes into 8 twice. 2 times 3 is 6. Subtract and get a 2 to 0. 3 goes into 26 times. 6 times 3 is 18. Our remainder is 2. We know our denominator is 3. Our whole number, part of our solution, is 26, with 2/3 left over. So P is equivalent to 26 2/3.